So 2.1, we're going to talk about how to use your compass. So you're going to want to have a compass nearby so we can practice using it. And then we're going to learn about some segments too. By the end of class, you'll be able to use your compass and work with segments. You need to know it because using your compass is required for your constructions. And they're kind of basic tools that you just need to know how to use. And then the how. You get it when you can do the constructions that we're going to talk about. You also want to make sure that your lines from your circle, your curves, your arcs are going to be clean and crisp, and you'll be good. So first, what is a construction? It's just a technique for accurately drawing figures using a compass and a straight edge. A reference line is just a line that you draw with a straight edge, and it's going to help you out with the construction. So it's just a straight line you're going to draw that's going to help with the construction. A reference arc, kind of the same thing. It's just an arc that you're going to draw to help with the construction, to assist with the construction. An arc is just a part of a circle. So looks kind of like that. It's part of a circle, but it's going to be perfect. When you use your compass, it'll be perfect. And a measurement arc is an arc that you draw with your compass where the radius is the length that you need. So you're going to stretch your compass to get the measurement, to get the actual length that you need. And that's a measurement arc. Couple of basics about your compass. You got to have a sharp pencil, otherwise it's not going to work. Make sure that the pencil and the point of the compass, when you push them together, that they match up in pretty much the same location. You want them to be sticking out about the same amount. So when you stick your pencil in there, it's got to stick out to where the point sticks also. And then when you're ready to use your compass, you open it up however much you need to, the radius of the circle that you're going to draw, and you're going to place a point on the paper. And when you are drawing, a lot of places that will tell you that you should draw circles with your compass like this. I disagree. That way's hard. I say that with your writing hand, so for me, it would be my right hand. You hold the compass down by the point, and you hold that still on the paper, pressing it down to hold it still. And then your pencil just kind of rests easily on the paper. And then for me, I always think it works better when I turn the paper instead of turning the compass. Turn the paper instead of turning the compass. I think that works better. Now, the other thing that helps out is if you angle your compass so that you're dragging the pencil around the paper rather than holding the compass straight up and down. This guy, I would say, is holding it too vertical. You need to tilt it down a little bit. So now we're going to use our compass for real. We're going to make an actual circle. So you should have 2 points, C and P. C is going to be the center of the circle, and we're going to draw it so that it goes through P. So we want to make a circle where C is the center and P is the point that it goes through. So you're going to take your compass, and you're going to put the point of your compass on the center. Yeah. So you need to stretch your compass so that the pencil touches P. Stretch your compass so that the pencil reaches P. And then hopefully as you've practiced, you can draw a smooth circle going all the way around. Yeah. So when you construct a copy of a line segment, you just first need to have a line segment. So if you don't have a line segment in front of you, draw one real quick. Label the endpoints T and W. Doesn't matter how big you make it, doesn't matter. Just do T and W. So what we're going to do is we are going to copy it. We're going to copy it. So we're going to start by drawing a line. That line needs to be longer than the line segment that you are copying. It needs to be longer. So however long you think it needs to be, make it a little bit longer so you know for sure it's longer. And we're going to label one of those endpoints. So this one's going to be like our new T. Do a prime. It's kind of like a prime. We transformed it. So you're going to then take your compass to measure the length of TW. With the compass, we're going to measure the length of TW. So put 1 point on T and stretch it out so that the pencil goes to W. So by stretching it out from point to point, you measured how long that is with your compass. I don't care the actual numerical distance. We just want that it's that long. So we're going to copy that down. So that means we're now going to take our sharp point on our compass down to the new line where we're going to draw it, the reference line. And it needs to be that long. So now you just got to wiggle your pencil a little bit. And that mark that you made, the arc, tells you how far away W is supposed to be. And now they're the same length. You can take your compass back and forth. You got the correct length. And still the same length. They're the same length, so they're copies of each other. That's it. So we're going to use that same idea of copying a line segment to make an equilateral triangle. Remember, equilateral triangle is just triangle with 3 equal sides. So we're going to start with our reference line, any line you want. Right there. And that's going to be like the bottom side of our triangle, of our equilateral triangle. It's got 2 endpoints here. So we need the other 2 sides to be that same length. So we're going to take our compass. Stretch it out so we know how long that segment is. So the other 2 sides have to be that same length. Now, since you've probably seen an equilateral triangle before, you can have a pretty good guess as to where it's going to meet. So looking at this equilateral triangle, my guess is that it would go somewhere up here, which means they're probably going to intersect up there somewhere in that yellow highlight circle I just did. So the only reason that we want that is because now that we're going to actually use our compass, we want it to pretty much just touch that yellow spot that I suspected they were going to intersect. From the judging here by this, I almost messed up. So we did it from one side. Now move it to the other side and do the same thing. And it was right up here at the top is where they intersected. Wherever those 2 points intersect, that's going to be the top of our circle. So that just means we need to draw in the 2 sides now. And now we've got an equilateral triangle. You can pull out a ruler, you can measure them, they're going to be the same. We know they're going to be the same because the compass shows us same length and same length. They're all the same length, so it's equilateral triangle. So next we're going to talk about a postulate. It's called the segment addition postulate. And before we go through and understand what it says, postulates, I always just call them duh statements. Duh. Because when you read it, once you understand what it's actually saying, you feel like just saying duh. It doesn't even, like, why did we even have to write that down? That's so simple. That's pretty much what they are. So, actually, even if you go way, way back to Euclid, and when they talked about postulates back in ancient Greece, that's what they said a postulate was. It means it's a statement that is so simple it doesn't need proof. It's so simple and basic, you don't need to prove it. People just will accept it because it's that obvious. So, statement. So, given 3 collinear points, let's dig into this and see what segment addition is talking about. A, B, and C, they're all on one line. And B is in between A and C. The lengths of AB and BC together, those lengths will equal the length of AC. So I color coded it here so I can just say the yellow part plus the green part is the whole thing. Duh. It's a postulate. It's supposed to be duh. It's not anything exciting. So now we've got distance formula. Distance is between 2 points, or sometimes it'll be the length of the segment. It's kind of the same thing. You should recognize this from Algebra 1. So now we're going to use that distance formula to find the distance between these 2 points. So the first thing I always do, and I've been doing these quite a long time, I always label them XY, XY, and I put on the 1s and the 2s. This is X1, Y1, X2, Y2. That way, when you plug it into the formula, you know exactly where it's going and everything. So, formula one more time. That's the formula for distance. That's the distance formula. So, right underneath X2, I'm going to write X2, which is 5. And then underneath X1, we put -1. So that's what it is. Squared. Y2 is 6. Y1 is -2. And that's squared. Always do inside the parentheses first. So 5 minus -1, that's like turning to a +1. So that's 6 squared. 6 minus -2, that's plus. So that's 8 squared. 6 squared is 36. 8 squared is 64. Add those up, you get 100. And the square root of 100 is 10. So the distance is 10. So here's another example. We're going to do the same thing. Label your x, y. And label your 1s and 2s. I always write the formula. And then just plug it in right below. So x2 is 5. x1 is -1. y2 is 7. y1 is 2. Always do inside the parentheses first. So minus negative is like plus. That's 6 squared. And then 7 minus 2 is 5. Six squared is 36. 5 squared is 25. Add that up, you get the square root of 61. And it says use a calculator to approximate it to the nearest hundredth. I know that's going to be a little bit less than 8. Square root of 61 is 7.81.